The first questions, it's about these identities. Sine squared theta plus cos squared theta is identical to 1, and this can be rearranged to write sine squared theta is equivalent to 1 minus cos squared theta, and cos squared theta is equivalent to 1 minus sine squared theta. And the second identity that needs to be used for this sum is tan theta is identical to sine theta divided by cos theta. So these questions deal with this. The first one is 1 minus cos squared half theta. So this one would be 1 minus cos squared half theta is sine squared half theta using this rule. Question number B. 5 sine squared 3 theta plus 5 cos squared 3 theta. So 5 sine squared 3 theta plus 5 cos squared 3 theta. If 5 is taken common, it becomes sine squared 3 theta plus cos squared 3 theta. Now the identity is, if both have the same angles, they're identical to 1. So we can write 5 into 1, sine squared any angle plus cos squared that angle together is 1. So the answer is 5. Question number C. Sine squared a minus 1. Sine squared some angle a minus 1. Now in order to make this an identity, 1 minus sine squared some angle, we have to take minus common. It becomes 1 minus sine squared a, which is equivalent to cos squared a, and that is the identity. Then question number D. Sine divided by tan. Sine theta divided by tan theta. So we can write sine theta divided by, now tan theta is identical to sine theta by cos theta. If we change the division sign, it becomes cos theta divided by sine theta. This sine theta and this sine theta cancels and we get cos theta. Question number E. We have square root of 1 minus cos squared x, the angle theta is x here, divided by cos x. Now this would be square root of 1 minus cos squared x is sine squared x divided by cos x. So we have used the identity 1 minus cos squared theta is equivalent to sine squared theta. So here we can write sine squared theta. Now square root of sine squared theta is only sine theta, sine x, divided by cos x. So sine x by cos x, we have the identity tan x. Question number F. Square root of 1 minus cos squared thrice a divided by square root of 1 minus sine squared thrice a. Now 1 minus cos squared is sine squared. So square root of, we can write here sine squared thrice a divided by square root of 1 minus sine squared is cos squared. So this is cos squared thrice a. So this would be square root of sine squared thrice a is sine thrice a, and square root of cos squared is cos. The angle would be the same. Now we know sine of any angle divided by cos of that angle is identical to tan theta. So tan thrice a. Question number G. Question number G uses 1 plus sine x whole squared plus 1 minus sine x whole squared plus 2 cos squared. So what we can do over here, so we have 1 plus sine x whole squared plus 1 minus sine x whole squared plus 2 cos squared x. Now we can write, if we break this down, 1 plus sine x whole squared is a plus b whole squared. So a squared plus 2ab is 2 sine x into 1 plus b squared is sine squared x plus 1 minus sine x whole squared is a minus b whole squared. A squared minus 2ab is 2 sine x plus sine squared x. Now we have 2 cos squared x, 2 cos squared x. Now plus 2 sine x cancels with minus 2 sine x. and plus 1 becomes 2. So let me write it over here. So this is going to be 1 plus 1 is 2 plus 2 sine x squared plus sine x squared is 2 sine x squared. So 2 sine squared x, not sine x squared. The angle would be the same. 2 sine squared x. And we have 2 cos squared x. So this would be 2 plus, if we take 2 common here, it becomes sine squared x plus cos squared x. So 2 plus 2. Now we know from the identity sine squared of some angle plus cos squared of the same angle is always 1. So this would be 4. 2 plus 2 is 4. The next one is question number H. In H we have sine to the power 4 theta plus sine squared theta cos squared theta. If we take sine squared theta common like some algebraic expression, we get sine squared theta over here because it was sine to the power 4 plus this sine squared goes common, we get cos squared theta. Now we already know sine squared theta plus cos squared theta is 1. So this would be sine squared theta times 1 and the value would be sine squared theta. The next one is I. We have sine to the power 4 theta plus 2 sine squared theta cos squared theta plus cos to the power 4 theta. If you take a look over here, it's like a squared plus 2ab plus b squared. Sine squared theta is like a, cos squared theta is like b, and the first one, sine to the power 4 theta, is sine squared whole squared. So we can write it as a plus b whole squared, which is the same as sine squared theta plus cos squared theta is 1. So we can write 1 whole squared, which is 1. Question number 2 is using the same identities as before, but this time we don't have to simplify, we have to prove left hand as right hand. A. We have to prove that the left hand side sine theta plus cos theta whole squared, let me write left hand side sine theta plus cos theta whole squared is identical to the right hand side. So let's break this down. So a plus b whole squared is a squared plus 2ab, which is sine theta cos theta, plus b squared, which is cos squared theta. Now we know sine squared theta here plus cos squared theta here is 1. So we can write here 1 plus 2 sine theta cos theta. And that's exactly that we have to prove. So we can write, therefore, left hand side is identical to the right hand side. So question number B, we have to prove left hand side is 1 by cos theta minus cos theta. So 1 by cos theta minus cos theta. So the LCM is going to be cos theta. So this is going to be 1 minus cos theta is going to be cos squared theta by taking the LCM. Now we know 1 minus cos squared theta is sine squared theta. Now this is divided by cos theta. Now we have to prove that it is sine theta tan theta. So let's break this down. Let's write sine theta times sine theta. So that is sine squared theta and this is cos theta. So we can write here sine theta and we can write it sine theta by cos theta is tan theta, and that's what we have to prove. So this is left hand side is identical to right hand side. The next one is question number C. Question number C, the left hand side that we have is tan x plus 1 by tan x. So let's simplify. So if tan x is the LCM, then we can write tan x is tan squared x plus tan 1's a tan, so this is going to be 1. Now what we have to prove over here is 1 by sine x cos x. Okay, so what we can do is we can write it as tan x as sine x by cos x, and tan square x as sine x by cos x whole squared plus 1. So we can write it as sine squared x by cos squared x plus 1, and downstairs we have sine x cos x. So if we take the upstairs LCM to be cos squared x, so we have cos squared x, so that would be 1. That means it would be sine squared x, and 1 times cos squared x is going to be cos squared x, and downstairs we have sine x by cos x. That means upstairs sine squared x plus cos squared x is going to be 1 divided by cos squared x. So this is going to be cos squared x, and we have sine x divided by cos x. Now if we write it as division, it would be 1 by cos squared x divided by sine x by cos x. If we further simplify that, it would be 1 by cos squared x multiplied by cos x sine x. Now this cos squared x and this cos x cancels off, and we have 1 by sine x cos x. Now another way of simplifying the same sum is starting from the beginning. So what we could have done over here is we could have started from the beginning as sine x by cos x, breaking down the identity of tan x, and we can write 1 by tan x as 1 by sine x cos x, meaning cos x by sine x. Now if we take the LCM, it would be sine x cos x as the LCM, and it would be cos x, that is 1. So we have sine x left here, so sine x into sine x is sine squared x, plus similarly sine x matches, so cos x is left, this would be cos squared x. So we can write sine squared x plus cos squared x is 1. We can write 1 by sine x cos x. So the same sum can be done in two different ways. One is a shorter method. We can therefore write left hand side is identical to right hand side, and another one is a longer method. We can write left hand side identical to right hand side. So that's the same sum can be done in two different ways. The next one, question number D, is the left hand side is cos squared a minus sine squared a, and we have to prove that it is any one of the, because there are two identical symbols, so we can just start with any one of them. So we can write left hand side cos squared a minus sine squared a. So if we want to express it as cos squared a, as since there are two different identities, either you can prove as this or you can prove as this. I'm going to prove the first one, so I need cos squared a. I'm going to leave the cos squared a as cos squared a, and I'm going to change the sine squared a as 1 minus cos squared a. Remember, that's the identity. So if I remove the bracket, it becomes cos squared a minus 1 minus minus plus cos squared a, and it turns out to be cos squared a plus cos squared a is 2 cos squared a minus 1, and that's exactly the identity, 2 cos squared a minus 1. That's all we had to prove, and that's therefore left hand side identical to right hand side. Now if we had to prove the second one, 1 minus 2 sine squared a, all we have to do is keep the sine squared a and convert the cos squared a as 1 minus sine squared a, and that would turn as 1 minus 2 sine squared a. Question number E. The left hand side is 2 sine theta minus cos theta whole squared plus sine theta plus 2 cos theta whole squared. So the left hand side is 2 cos theta plus minus cos theta whole squared. So 2 sine theta minus cos theta whole squared plus sine theta plus 2 cos theta whole squared. If we break down the bracket, it would be a minus b whole squared. So 2 sine theta whole squared is 4 sine squared theta minus 2ab would be 2 to the 4 sine theta cos theta plus b squared would be cos squared theta plus, now sine theta plus 2 cos theta whole square is a plus b whole square. This would be a squared, which is sine squared theta, plus 2ab would be 4 sine theta cos theta, plus b squared would be 4 cos squared theta. Now minus 4 sine theta cos theta and plus 4 sine theta cos theta cancels off. What we can write now is 4 sine squared theta plus sine squared theta is 5 sine squared theta, and cos squared theta plus 4 cos squared theta is 5 cos squared theta. If we take 5 common, sine squared theta plus cos squared theta is going to be 1, and the answer is going to be 5. 5 ones are 5. Therefore, left hand side is identical to right hand side. The next identity is question number F. So where we have, so let me put it over here. So this is going to be 2 minus bracket open sine theta minus cos theta whole squared. So let me left hand side 2 minus, let me see this again, 2 minus sine minus cos whole squared. So sine theta minus cos theta whole squared. So this is going to be 2 minus a minus b whole square is going to be sine squared theta minus 2ab, 2 sine theta cos theta plus b square is going to be cos squared theta. So now 2 minus sine squared theta plus cos squared theta is going to be 1 minus 2 sine theta cos theta. If we open the bracket, it will be 2 minus 1 plus 2 sine theta cos theta. 2 minus 1 is going to be 1 plus 2 sine theta cos theta. So let's check what we have to prove. So we have to prove sine theta plus cos theta whole squared. Now instead of 1, we can write sine squared theta plus cos squared theta, and we already have 2 sine theta cos theta. So this can be rearranged as sine squared theta plus 2 sine theta cos theta plus cos squared theta, which is the same as a squared plus 2ab plus b squared. We can write sine theta plus cos theta whole squared. If we break it down, we again get this the previous line. So therefore, left hand side equals to right hand side. Question number G, we have to prove sine squared x cos squared y minus cos squared x sine squared y. So sine squared x, let me check this again. Sine squared x cos squared y minus cos squared x sine squared y. So this is the left hand side that we have. The trick with this sum is that we have sine squared y here, so we need to convert this into sine squared y, and we have cos squared x over here, so sine squared x has to match with cos squared x. So let's convert this, and the reason I'm converting everything into sine squared x, because in the question the answer should be only in terms of sine squared x and sine squared y. We have to get rid of cos squared y. Let's start. So sine squared x, so we can write it as 1 minus sine squared y minus cos squared x would be 1 minus sine squared x, and we have sine squared y. So if we multiply, it would be sine squared x minus sine squared x sine squared y minus, if we multiply this, it would be sine squared y minus sine squared x sine squared y. If you open the bracket, it would be sine squared x minus sine squared x sine squared y minus sine squared y, and this minus becomes plus. It would be sine squared x sine squared y. So this thing and this thing cancels, and the answer is sine squared x minus sine squared y. And this is exactly what we had to prove. So left hand side is identical to right hand side.